let's talk about arrays. This is our first data structure that we're going to learn. So we might want to store multiple information together. Maybe they have a meaning together, right? For example, a student's exam grades and their final, let's say they have 2 exams and a final, that 3 numbers should be stored together. If those 3 numbers are stored together, they have a meaning. Like we can calculate the average. Storing those information together right next to each other is done by using arrays and linked lists, but we're going to learn about linked lists later. So let's take a look at arrays first. In arrays, we store information by putting the information next to each other in the memory, right? For example, bits. One bit is a 1 or a 0, and we can combine 8 bits, 1, 2, 3, 4, 5, 6, 7, 8 bits, and this would give us a byte. And you would store these right next to each other in the memory, and that's what arrays do. Let's go back to the earlier example, and let's assume that we're storing 2 exams in a final of that student's. So we can represent those numbers using 4 bytes, which would be 32 bits, 32 individual places. And so in an array, you would put those 4 bytes, 32 bits, right, 32 bits. Let's say you're storing here, and right next to it would be the second exam grade, again, 32 bits. And right next to it would be our final exam grade, which would be, again, 32 bits. The point of array is that they're just right next to each other. Let me explain it using a different analogy, a different example. So let's assume that you and your 3 other friends want to watch a movie together, but you have this one rule that you all have to sit right next to each other. So you and your 3 friends, so 4 people, go and pick, and you sit here. And then the ones that are marked red are filled. So another friend of yours comes, and you all want to sit together again. So you have to find another seat which has 5 seats right next to each other. So you find it, you and all of your friends now move together to this new seating. You and your friends have to get up and sit on the next seating. And if another friend comes, now you have to find another place, and then everyone has to move and go to that place. So that's how it is in arrays. And this could be a good thing. You're next to each other, so it's easier to find your friends, everything is easier. But also it could be a bad thing because now you have to move every time when a new person comes. So one other thing you can do is you go to the movie theater and you pick 10 seats in a row. You have 4 friends already, and you don't know how many more are coming. You're just gonna occupy 10 seats. Is this an optimal solution? No, it's not, because you're actually wasting memory, right? In the computer, if you're keeping a space that you're not using, you're just wasting it. Same thing goes for the movie theater. You're not letting other people watch it. You're just keeping seats that are empty and might not be used. So that's actually one of the negatives of array. It's called a dynamic array when it's changing sizes. Usually arrays have a set size. You have to know how many people are coming to the movie theater, and you pick that many seats. And if one more person comes, it just doesn't work. But in a dynamic array, you can pick multiple seats, and then as people comes, they sit, and you always have like empty spaces, right? They sit. But one of the other downsides of this is that, let's say you have 10 spaces and 11th person comes, and now you get 5 more seats, so you have 11 people but 15 seats. So still you have more empty seats, and you're always occupying more space than you need. But one of the positive of arrays is that you know where everyone is. They're just right next to each other. And as I said, the same thing goes for how it is in the computer and memory. They're physically right next to each other. When you want to find the person on the seat number 5, you just go there and you find the person. So you know where everyone is. But again, one of the downsides is that when someone new comes, either you have to move to a completely different place, everyone has to move together, which is, again, computationally expensive, or you have to keep spaces that you're not using. But linked lists have a different approach to this problem, and we're going to learn about that in the next video.